Good morning, Chennai. Welcome to Gates on Coimbatore. Myself, Besli. இன்னைக்கு நம்மோட யார் இருக்காங்கன்னா Franklin இருக்காங்க. இன்னைக்கு நம்ம IPL ஆட போறோம். IPL எதை பத்தி பார்க்க போறோம்னா structural members in deformal bodies பத்தி பார்க்க போறோம். அத பத்தி classification அதோட formulas எல்லாம் பார்க்க போறோம்.
So structural members in strength of materials are broadly classified into three categories: axial members, then transverse members and torsional members. Three categories. Structural members, on what basis the structural members are designed, and on what basis the beams or transverse members are designed, or on what basis a torsional member or shafts are designed. So this we will see today. First one, axial members are designed based on strength and stiffness. So what do you mean by generally, what do you mean by strength? So it is the ability to withstand the external force or load without deformation or without failure. That is called the strength. So as per Hooke's law, we know that this is the axial members. If you draw the stress strain diagram, so this is the stress strain diagram for a mild steel or any ductile material. So up to this proportional limit, the stress is proportional to the strain. So this stress divided by strain, this is a constant. This constant we are calling it as Young's modulus. From this we can find what is this strength or stress. So strength is nothing but this is sigma equal to Young's modulus multiplied by the linear strain. Then the second criteria is stiffness. Generally stiffness means the ability of material to withstand deformation. So it takes a load without deformation, or then generally we can define this as load per unit deformation is called the stiffness. So K equal to load by deflection, like that we studied in engineering mechanics. So we know this deflection because of this load, the deflection is PL by AE. From this P by delta L we can write it as EA by L if you do it cross multiplication. So this term EA by L is otherwise known as the axial stiffness. Okay, so this is axial stiffness. So this axial member is based on two criteria: one is strength, another one is stiffness. Then second one is the bending member or the beams. So again these are also designed based on two criteria, same criteria only, strength and stiffness. Here the basic equation we are using is the bending equation, M by I equal to sigma B by Y equal to E by R. Now if I equate these two, I will get this strength, M by I equal to sigma by Y. So from this I can find what is sigma B. Sigma B equal to My divided by I. So this is the strength. So from this I can write this is M divided by I by Y. So the term I by Y we are calling it as section modulus. Again second thing is this stiffness. I am equating these two equation, M by I equal to E by R. From this I can get this radius of curvature as M by EI. So the term EI here we are calling it as flexural rigidity or bending stiffness. And the third member is the torsional member. It is shaft. So the general torsion equation is T by J equal to C theta by L equal to tau by R. So if I equate these two, strength equating, sorry, this one and this last one, this is the strength criteria. I want to find what is the shear stress. Stress induced in a torsional members are shear stress only generally in case of pure torsion. So from this I can find what is tau. Tau equal to TR divided by J. Again I can write it as T by J by R. The term J by R is otherwise known as polar modulus. Again the second criteria is, here stiffness means load by deflection, it is the linear deflection or vertical deflection. Here rigidity means angular deflection, load per angular deflection, it is nothing but T by theta. This is called rigidity. So if we equate this first and second, T by J equal to C theta by L. So from this I can write T by theta cross multiplication, T by theta equal to Cj by L. So the term Cj by L is known as torsional rigidity. So generally in our strength of material books we design these members based on these criteria only, but generally while designing torsional members or shaft we have to consider the whirling speed of this shaft or critical speed of this shaft also. So the critical speed of this shaft is normally, this is equal to the natural frequency of transverse vibration. So once we know this natural frequency of transverse vibration, that is equal to, this will be in RPS, Hertz is nothing but RPS. So multiplied by 60 will give you the whirling speed. So based on this, we can decide. These are all this.
இன்னைக்கு நமக்கு என்ன சொல்லிருக்காங்கன்னா ஸ்ட்ரக்சரல் மெம்பர்ஸ்ல ஆக்சியல் மெம்பர்ஸ் பெண்டிங் அடுத்த டார்ஷனல் இருக்கக்கூடிய ஃபார்முலாஸ் அதோட ஈக்குவேஷன் சொல்லிருக்காங்க. அதுக்கு அவங்க தேங்க்ஸ் சொல்லிக்கலாம். தேங்க் யூ சாம்பியன்ஸ்.